Here is the page 7 and 8 of the logarithm lectures. If both sides of an equation are blank, we can take the log of both sides without changing the solution. Well, remember that you can only take the log of a positive number. So we could say if both sides of the equation are positive, then we can take the log of both sides. Now we'll start with the odds. So let's see, y equals 2 to the x. Write the following as log equations in base 10, assuming all terms are positive. So for this one, we'll just take the log of both sides. That would be log of y equals log of 2 to the x. And log of y can't be simplified anymore, but log of 2 to the x, you could put the exponent out front, right? Because of one of the rules of logs we know. Okay. C. M equals a d to the fourth. So well, the log of m is equal to the log of a d to the fourth. We could put this is the log of two sums, or the sum of two logs. And then we could put the 4 out front. Okay? Alright, now go on to E. R equals B square root of L. So that would be the log of R is equal to the log of B plus the log of square root of L. Square root of L is the same thing as L to the 1/2. So we could rewrite that as 1/2 log of L. I. L equals AB over C. The log of L is equal to, and so AB is a product, so we could do log of A plus the log of B. C is the divisor, so we could put minus log of C. Do G. Y equals AB to the x. Log of y is equal to log of a plus log of b to the x. Log of b to the x can be written as x log of b. K. S is equal to 200 times 2 to the t. Log of s is equal to log of 200 plus t times log of 2. Okay, moving on to number 2. Write the following equations without logs. We're doing A, C, and E again. So A, the log of D is equal to the log of E plus the log of 2. So in order to write this as without logs, what we could do is we could take both sides to the exponent of 10. So we could put 10 to the log D is equal to 10 to the log E plus log of 2. That could be written as 10 to the log D, of course, is just D. 10 to the log E would be 10 to the log E times 10 to the log of 2. And so D would equal to E times 2. Okay, C. Log of P is equal to 1/2 log of X. We could take both sides to the 10th power. That would give us P equals, this could be written as 10 to the log X to the 1/2. So this just becomes X. So it's P equals X to the 1/2. E. Log of B is equal to 3 log of M minus 2 log of N. We'll take both sides to the 10th power, and that'll give us B equals 10 to the 3 log M divided by 10 to the 2 log N. And so that's the same thing as 10 to the log M cubed over 10 to the log N squared. So that's the same thing as M cubed over N squared. Okay, and then G, log of P is equal to 3 log of X plus 1. Take both sides to the 10th power. 10 log of P is just P. 10 to the 3 log X plus 1 is 10 to the log X times 3 plus 10 to the 1. P is equal to X to the 3rd plus 10. Okay. Number 3. Write 3 times 2 to the x as a logarithmic equation in base 2. Okay. So the log of y is equal to log of 3. Log base 2 of y, log base 2 of 3, plus log base 2 of 2 to the x. Log base 2 of 2 to the x is just equal to x. Okay, so now we have log base 2 of y is equal to log base 2 of 3 plus x. Then it says, hence write x in terms of y, so we just need to isolate x. We can do that by subtracting log base 2 of 3 from both sides. So that would be log base 2 of y minus log base 2 of 3. Okay, find x when y equals 3. When y equals 3, this would be the answer to B. This is the answer to C1. When y equals 3, that would just be log base 2 of 3 minus log base 2 of 3. That would be 0. 2, that would be log base 2 of 12 minus log base 2 of 3. Log base 2 of 12 is the same thing as log base 2 of 3 plus log base 2 of 2 squared, because 12 is equal to 3 times 2 times 2. And then that would be minus log base 2 of 3. And now you see that we got a positive log base 2 of 3. We got a negative log base 2 of 3. Those cancel out. Log base 2 of 2 squared would be 2 log base 2 of 2. Log base 2 of 2 is just 1. Right? So that would just be equal to 2. 3, when y is 30, so that would be x equals log base 2 of 30 minus log base 2 of 3. So let's see, log base 2 of 30, you could write that as log base 2 of 3 plus log base 2 of 10, because 3 times 10 is 30. And then we have log base 2 of 3, subtracting it, and then we subtract one from the other, you get just log base 2 of 10. Okay? All right, last one, number 4. Solve for x. So we have a log base 3 of 27 plus log base 3 of 1/3 equals log base 3 of x. We'll just do A, C, and E of these. Okay. Let's see. We're going to take both of these to the power of 3. So we'll do 3 to the power of this equals 3 to the power of that. So 3 to the log base 3 of x gives you x. 3 to the log base 3 of 27 plus etc. is going to give you a 3 to the log base 3 of 27 times 3 log base 3 of 1/3. And then this is just 27 times, and then this is just 1/3. And that is just equal to 9. C. Log base 5 of 125 minus log base 5 of square root of 5 is equal to log base 5 of x. Now we want to solve for x, so we just take both sides to the power of 5. So it's 5 to that, 5 to that. 5 to the log base 5 of x is just x. 5 to the log base 5 of 125 minus log base 5 of square root of 5 would just be the product with the same base here. We'll just write it out here. Except, yeah, it would be like a fraction, right? 5 log base 5 of square root of 5. And then, so this would just be 125 divided by 5 log base 5 square root of 5 equals x. And then we would have 5 times 5 times 5 on top, divided by 5 to the 1/2. And so that would be 5 to the 2.5 is equal to x. Okay. And then the last one is E. Log base x plus log of x plus log of x plus 1 is equal to log of 30. And log of x plus 1 is the same thing as, let's take both sides 10 to that, so it'll be the right side will be 30, the left side would be 10 log of x times 10 log of x plus 1, and then this would just become x, this would just become x plus 1, multiply times each other equals 30. So that would be x squared. Well, you can kind of see what this is already, right? A number times the next number would be 5 times 6 equals 30, right? So x is equal to 5. You could factor it or make it into a quadratic, but that one's pretty easy, right? Okay, that's it for today.